Hi class, this is lesson 5-3 in your textbook, and it's titled How to Use Angle Bisectors of Triangles. So the last lesson we were talking about perpendicular bisectors, and now we're just talking about angle bisectors. So it's not bisecting a segment, it's bisecting an angle. And here's our first theorem, Theorem 5.5, and it's called the Angle Bisector Theorem. And it says if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. Okay, so in this case, AD is the angle bisector, and I had markings here to show that these two angles were congruent, and it's saying that this point is equidistant from the two sides of the angle. So what I'm going to write down is if AD, if that ray bisects angle BAC, and if DB is perpendicular to AB, and if DC is perpendicular to AC, then DB, that length, is equal to DC, that length. Okay? So if AD bisects this big angle, and if this segment is perpendicular to AB, and if this segment is perpendicular to AC, then those two lengths are equal to one another. Well, there's a converse to this, just like many of our other theorems, and the converse is Theorem 5.6, the converse of the angle bisector theorem. And what it says is if a point is now in the interior of an angle, so this is right here, and is equidistant from the sides of the angle, then it lies on the bisector of the angle. So I'm going to label a couple more points here. This is B, this is C down here. So if I have this point right here in the middle, okay, and it's equidistant as shown in this diagram, that both of those segments are exactly the same, then it has to be on the bisector of the bigger angle. So let's write this down in words. If DB is perpendicular to AB and DC is perpendicular to AC, and if the lengths BD is equal to CD, then I can conclude that AD is bisecting that big angle BAC. Okay? So let's go ahead and do a couple examples based on these two theorems. Our first example is asking us to find x so that P is on the bisector of angle BAC. So using the converse that we just learned, let's find out what x would need to be so that both of these segments would be equal to one another, and therefore P would be on the bisector of angle BAC. So I'm wanting to prove that BP is equal to CP. So I just need to find out what x would be for this to be true. So x plus 3 is equal to 2x minus 1. If I subtract x on both sides, I'm left with x minus 1 there. And now if I add 1 to the other side, I have x needs to be equal to 4. So if I was going to write this as my answer, I would say when x equals 4, P is on the bisector of angle BAC. But that's the only time that that would actually work. Okay? Here's another example. This time find the value of x again, but x is in the unknown angles. Okay? So I am told right here that both of these segments are exactly the same. Okay, it's shown that they're congruent, which means that their lengths are the same. So they are both equidistant. This point is equidistant from those two sides of the angle. And since that's true, I can conclude that the two angles themselves are equal to one another. So let's write that down. 3x plus 5 is equal to 4x minus 6. And then let's solve for x. I'm going to subtract 3x on both sides. So I'm left with just 1x over there. And then I'm going to add 6 to both sides. So I found that x is equal to 11. So if I plug that in, then I would be able to find that both of those angles are exactly the same. Over here, I would get 38 degrees. And over here, 44 minus 6 is also 38 degrees. So it was an angle bisector. Awesome. Okay, we're going to move on to the end now. Pretty short lesson. Theorem 5.7 says it's called the concurrency of angle bisectors of a triangle. Okay, it's kind of a mouthful. We talked about concurrency yesterday, where those three lines were meeting. Okay, so this theorem, it says that the angle bisectors of a triangle, okay, intersect at a point that is equidistant from the sides of a triangle. Okay, so you're trying to envision in all three of those corners of a triangle, we're bisecting each of those corners. So let me show you this example diagram that I have here. Okay, so this corner right here that's with the vertex A, I drew an angle bisector, so it's cutting that in half. And at B, I drew an angle bisector. And then at C, I also drew an angle bisector. And what it says is that if you have this and they meet at a point P, you're going to be able to find that this point P is equidistant from all three of those sides. Now, the way that we're going to do this is by drawing where this point comes at 90 degrees to each one of those sides. And all three of those segments are exactly the same length. It's pretty awesome. So I'm going to write that here. If AP and also BP and also CP are all angle bisectors of triangle ABC, then PD is equal to PE is equal to PF. And that's it. Okay? The very last thing that I want to say is that this point in the middle, this has a name as well, and it is called the in-center of the triangle. So that's just another term that I want you to know. So this is all that we're going to cover today. So if you have any questions, come with them when we meet back together tomorrow in class.